talk. So parameterization. So basically, what we will learn and study for some time is the concept of a curve. So what is a curve? So the typical answer provided since preschool is this is a curve, right? Isn't that what a curve is? So that's how people usually answer that question. What is a curve? This is what it is. Look at this. Is that a curve? Yes, that is also a curve. So can we explain better what the curve is? What is it that I did? I did this drawing. What's the drawing? Was it important to have a marker as opposed to something else? No. So a lot of things are not important and irrelevant to the concept of a curve. Who draws the curve? What is used to draw the curve? It is something, the concept out there, right? The concept of a curve that is important. So basically the drawing is a way listen carefully to that. So the drawing is a way to assign a point to any given time, in the sense that when I draw a curve, it means that my marker shows up at certain point at specific time. Right? So I begin at some time, I draw and I end at some time, and that association is what we consider a curve. Given time, a point. And you can see it actually so let me illustrate that. So this is a curve right? So the reason I'm showing you that movie is that now you see the timeline. Okay? So the association is you take this timeline, and for every moment of this time, for every point of this timeline, you associate a point right there. Right? And you know how it works, right? You choose time here, and this is the point. You choose a different time, it's a different point. And for any time here, you have a point there. So that's the very practical way of seeing that association, that assignment. And that assignment is called a function. A function that takes this line, and this line is not kind of physical line anywhere, right? It's timeline. So you can only imagine that line. You can draw it, of course. But the meaning of it is time. And then the function goes from this timeline to reality. Well, of course, that abstract reality, to that plane in this case. And the way it goes is that, well, each of these points is getting a point there assigned. So as opposed to the function you studied in calculus 1, 2, the function that associates a number to a number, taking a line to another line, what we will study now is an association of a point on a plane to a number. It is also a function, it's just a different type of function. So it is a function like from a line to a plane. Well, the strange thing about this curve is that for the last couple of seconds, the marker is staying at the endpoint. It's still there. So it could be that I stop drawing and a lot of time is spent at that point. So that makes more sense. Well, geometrically, I'm still drawing 1 point for 2 seconds, right? So geometrically, it doesn't make much sense that we spend too much time on 1 point. We usually spend 1 instance on 1 point. But from physics point of view, it will make sense if you think about the whole scenario in a way that instead of me drawing something, you think of a moving particle. Okay, so what you see here is trajectory of a particle, and position of the particle at a given time is provided by that function. And what this function says is that, well, particle is flying here, and by the time the particle gets to the ending point, it stays there for a couple of seconds. So from physics point of view, it makes much more sense to have sometimes a particle staying at a point, moving faster or moving slower, right? As opposed to geometric approach, when it doesn't matter at all. It's only the shape of the curve that matters. And now you see the difference of perspectives. Geometry takes only the shape into consideration, ignores the rest. Physics may take into consideration the function. And from geometric point of view, you may have a different function describing exactly the same curve geometrically. Right? Because someone can take a marker and draw the same curve backward, maybe slower, maybe faster. Right? Geometrically, it will be considered exactly the same. From physics point of view, thinking of a particle and trajectory of a particle, it will be different motion of a particle. It will be a particle moving backward, having different velocity. So we will keep switching points of view on the curve. Sometimes a curve for us is going to be a geometric object, regardless of how things are moving along the curve. But to be more practical, to be able to do computations, we will have to do some algebra about that geometric object. And in order to do the algebra, we will need parameterization. We will need to imagine a particle moving along the curve so that the curve is described as a function. And once it is described as a function, it gets a formula assigned. And then we can use formula to do all kind of fancy calculus stuff like differentiation, integration, and because otherwise geometric methods are very limited and calculus doesn't apply directly. Okay, so that's what parameterization is, essentially.